Hello everyone. In this video, we shall discuss how to solve inequalities that involve the absolute value. So we shall consider two cases, and the first case is when the absolute value of a times x plus b is less than or equal to k, where k is a non-negative real number. So for the solution of this particular problem, we shall use negative k is less than or equal to a times x plus b is less than or equal to k, and then we're going to solve for x. Now, if the inequality is strict, which means that there's an absence of the equal sign, then in the solution, we have to remove the equal sign as well. So for our first example, let's solve for the absolute value of 3x minus 7 is less than or equal to 8. So since this follows the format of case number 1, we can use the following formula. So therefore, in our solution, we have negative 8 is less than or equal to 3x minus 7 is less than or equal to positive 8. So we shall add 7 to all of them. So adding 7 here, we get negative 1. And then adding 7 here, we get 3x. And then adding 7 to 8, we get 15. So adding 7 will not change the sense of the inequality. And then to solve for x here, we shall divide by 3. So that means we have to divide everything by 3. So that means we get negative 1/3 here. And then 3 will cancel out. So we get x and then 15 over 2 in the following. So dividing by a positive number will never change the sense of the inequality. So for our solution, this means that we write this as negative 1/3 comma 15 over 3. And since both negative 1/3 and 15 over 3 are included, they will be preceded and followed by a bracket symbol. So this is the interval notation of our solution for this absolute value inequality. Now for our second example, let's consider the inequality 4 times the absolute value of 5x minus 1 and then plus 2 is less than 10. So observe here that we're using a strict inequality. So that means in our solution, we have to remove the equal sign as well. However, we need to solve first or separate first the absolute value on one side. So which means we're going to transpose positivity to the right side. So we get 4 times the absolute value of 5x minus 1 is less than 10 minus 2, which is 8. And then we're going to divide both sides by 4. So we get the absolute value of 5x minus 1 is less than 8 divided by 4, which is 2. So now this inequality follows the format here in case number 1. So in our solution, this should be negative 2 is less than 5x minus 1 is less than positive 2. So observe that there's no equality symbols in our inequalities. Okay, so to solve for x, we need to add 1 to all of them. And then the inequalities will stay the same. And then we divide all of them by 5. So our solution will be negative 1 over 5 is less than x, which is less than 3 over 5. So our solution set is written as negative 1 over 5 comma 3 over 5. And then they are preceded and followed by a parenthesis. So now what happens if the constant is a negative number? So for example, if we have the absolute value of 2x minus 9 is less than or equal to negative 3. Now, the absolute value in the left side will always be non-negative or mostly positive. And then the right side here is negative. So a positive number cannot be lesser than or equal to a negative number. So this means that this inequality doesn't have a solution. Now for the second case of absolute value inequalities, now we consider the inequality absolute value of ax plus b is greater than or equal to k. And then again, we restrict k to be a non-negative real number. So for the solution here, we shall solve for ax plus b is less than or equal to negative k. And we also solve for ax plus b is greater than or equal to k. Now, if the original inequality is strict, then that means the solution will not contain the equal sign. Okay, so let's have an example here. So let's solve for the absolute value of 4x minus 5 all over 3 is greater than 9. So observe here that our inequality is strict, and then this thing or this constant is positive. So we shall use the formula. So we write 4x minus 5 over 3 is less than negative 9. So we follow this formula. And then the second one is 4x minus 5 over 3 is greater than positive 9. So for both inequalities, we multiply both sides by 3. So we get 4x minus 5 is less than negative 27. And then for the second inequality, we get 4x minus 5 is greater than 27. So transposing the constant negative 5, we get 4x is less than negative 27 plus 5, which is negative 22. And then for the second inequality, that will be 4x is greater than 27 plus 5, which is 32. And then dividing both sides by 4, we get x is less than negative 22 over 4. And then dividing both sides by 4, we get x is greater than 8. So if we will graph the following, then negative 22 over 4 will be plotted on the real number line, and then positive 8 is positioned to its right. But since both of these values are not included, we represent them by a hollow point. And then for x is less than negative 22 over 4, that means everything to the left of negative 22 over 4 are solutions to the inequality. And x greater than 8 means that everything to the right of positive 8 are part of the solution of the problem. So to write the interval notation, that means we're going to read the graph from left to right. So we write negative infinity, comma, negative 22 over 4. And then this is not included. Union 8, which is not included. And then comma, positive infinity. Now for our second example, for case number 2, let's consider 3 times the absolute value of 6x minus 4 minus 8 is greater than or equal to 10. So first we shall transpose negative 8. So we write this as 3 times the absolute value of 6x minus 4 is greater than or equal to 10 plus 8 is 18. And then we divide both sides by 3. So we have the absolute value of 6x minus 4 is greater than or equal to 18 divided by 3, which is 6. So using the formula for case number 2, we have 6x minus 4 should be less than or equal to the negative of this number. And then the second one will be 6x minus 4 is greater than or equal to positive 6. So transposing negative 4, we get 6x is less than or equal to negative 2 for the first inequality. And for the second inequality, we have 6x is greater than or equal to 10. Now dividing both sides by 6 for both inequalities, we will get x is less than or equal to negative 2 divided by 6 is negative 1/3. And for the second inequality, that will be x is greater than or equal to 10 over 6, which is positive 5 over 3. So to write the solution set, we draw the number line, and then we plot the negative 1/3, and then 5 over 3 is positioned to the right of negative 1/3. So since there's the presence of the equal sign, that means that both of these boundaries are included in the solution set. And then x is less than negative 1/3 means everything to its left are included. And the x is greater than 5/3, that means everything to the right of 5 over 3 are included in the solution set. So therefore, the solution set will be negative infinity up to negative 1/3. Infinity is preceded by a parenthesis, and then negative 1/3 is followed by a bracket. Union 5 over 3 gamma positive infinity. So since 5/3 is included, that will be preceded by a bracket, and then positive infinity is followed by a parenthesis. Okay, now what if the right-hand side of the inequality under case number 2 is a negative number? So in here, as you can see, the absolute value is always non-negative or mostly positive, and then the right side is negative. Now, this would mean that um, everything or at any value of x that we substitute into the left side of the inequality will always result to a non-negative number, which is always greater than or equal to negative 8. So that means the solution set here is the set of all real numbers x. So which means we write it as negative infinity up to positive infinity. So this ends our video about solving inequalities involving absolute values. Thank you for listening, and I hope that you can subscribe to my channel. Thank you.